Hello everyone. So my name is Michael Schulz and I'm presenting our work for the GEO-AWS work on behalf of Said Hamzeh and Ali Nazravi of Babylon University. Our topic is the extraction of semantic features from OpenStreetMap using deep learning and Sentinel-1 and 2 data or Copernicus data for land use classification to support geo-wetland monitoring. Okay. So in essence, our problem is revolving around, as I mentioned, land use and land cover classification, and we are particularly interested in compositions of land use and land cover revolving around wetlands. So our study site, that's shown on the right-hand side with the red arrow, is directly at the border from Iran and Iraq, which is a small wetland, which is the Hura Lazim wetland. And if you zoom in at Google, you can see it very well. Or on the left-hand side is better. We have displayed two feature spaces, Sentinel-1 and Sentinel-2, which display this data. So what can you can see quite well that actually when you have a look at the very left bottom image, the radar data that you see there, that this wetland is impacted by different usage characteristics, which is pretty distinct. So this line that you can see there, marked by these three red arrows, this is actually the border between Iran and Iraq. So you can see that the western side, they use it in a different way than in the eastern side. In fact, on the western side, there's more water, more soil moisture available than on the eastern side, on the Iranian side. So there are different regimes, different usage regimes. So and we're wondering how this is impacting the wetland, how we can make use of land use information available to describe the evolution of the wetland. So we're trying to do this with spatial descriptions, with descriptive statistics and with fragmentation statistics. All right, well, another key aspect that the Amazon Web Service allowed us to do is to test different models and data setups, which is essentially also the core of our work, right? So we are exposed here to a certain problem where we are essentially using different setups of feature spaces, different setups of models, and different training data. Okay, let's move on. So to show you a bit the overview of our work. So we're using OpenStreetMap. If you don't know it, just Google it because time is sharp here. And we extract ways of land use. Ways are just a representation of OpenStreetMap to describe polygons, to describe our study site, our wetland. And then we use this information to train our feature space, which is the Copernicus data, to classify those areas which are unknown, right? So the kind of like the catch or the key of our approach is that we're trying to produce a remote sensing classification, however, without injecting or training or without capturing any training data by ourselves. So we're using OpenStreetMap to take the training data, which some people already collected for us, volunteer mappers. We use the Copernicus data, also was collected for us. And then we just use GPUs, different types of models, to classify those. And that's kind of like the key spot or the sweet spot. Without the Amazon computing powers, we could not link those two things together. Okay, this is a bit our workflow. Okay, so you can see when you look at the right hand side to the figures, you can see some classifications results. So right away you can see on the right hand side the OpenStreetMap data as it is blank, right? Just as you see it when you have a look at it at that very side. And on the left hand side, our representation and our classification of this wetland, including land use areas, particularly anthropogenic areas, because those are of prime importance of us, they are shown there. So as I already identified earlier, for us it's important to understand the different usage policies and the changes of this wetland, how this evolves over time. All right, so what you saw In our current activities, we were working with Sentinel-1 data and composites of Sentinel-1 data. Essentially, so we're using 5 bands, yeah, VV-min, VV-max, VH-min, VH-max, VV/VH constants, and also their residuals. And we essentially aggregated all Sentinel-1 scenes of 2019 and in some parts of 2020 with using median max and certain other parameters to construct a very dense remote sensing, in this case SAR, synthetic aperture radar information stack feature space. And the same thing we also did with an RGB data set, near infrared, for instance, and shortwave infrared extended to those RGB bands because those are available in 10 meters. Anyway, so these are the different feature spaces we were using, right? So we did our classification using just the radar data, just the Sentinel data. In both cases, pre-processing was particularly challenging for memory. If you have such a large area and you want to use all of the available Sentinel-1 and Sentinel-2 data, then you need a lot of RAM. And the cool thing was in Amazon Web Service, so we at the beginning for the pre-processing we were booking I think it was 0.5 terabyte of RAM instances to do the pre-processing, and then later we used the GPU instances, so we could kind of like flexible switch from the different needs that our processing chain had by those solutions available by Amazon Web Service. So that was very useful for us. So then we tested different suitabilities of training data. So we just randomized our setup just in a way as you do it. And then one of the key things was comparing the different model performances, deep learning, machine learning suitabilities, robustness, and more random forest based, which is a more robust one, but pixel based. So, well, one of the drawbacks with the deep learning was that it was kind of hard to optimize the model, to reduce the loss functions. So here you see the different scores that we have achieved, and the training data that we used was rather noisy. This is kind of like the catch. That's a bit about the drawback. So when you use OpenStreetMap data, cool thing is you don't have to train yourself, but you have to live with what people produced for you. And as a result, since the mappers are very heterogeneous, right, you have high quality, low quality, different types of qualities available. And as a result, we were kind of turning our attention, should we tune the classifiers only or should we tune the whole network? With classifiers, I mean, so we had 3 classes, urban classes, wetland classes, and other land uses. And then we also changed the amount of samples that were introduced. Usually with deep learning, you start off with more than 1,000 training sites. And this was a bit challenging in this area of interest because we just had few training sites available. So this is one of those areas where we have to either change the tag compositions which we use to extract training data from OpenStreetMap data, or in the worst case, collect training data by ourselves. But that's something that we want to avoid. So these are the different machine learning algorithms that we turned our attention to. Okay, I just see the times, but it's sharp on time. Anyway, next steps, we want to vary optimization functions to deal with this noisy training data, vary the feature space for them, test different models, and include more training data by adding more text. Okay, anyway, looking very much forward to answer your questions. Thanks a lot, and see you.